Greetings and welcome to another installment of QuantSlob. This is 18 in our basic application series. This time around, we're going to take a look at the sample. Although I will tell you that this title may be something of a misnomer here. Especially with the growing popularity of applied statistics, researchers nowadays spend more and more of their time head down in one data set or another. And of course, the term itself or title, data scientist, seems to reflect an emphasis on data. For this video, we're going to start by relating this thing data to something with which we are already quite familiar, simply and broadly, impressions. All statistical samples are impressions. All samples or data sets, all those that have been, are today, or ever will be, are, in the abstract, ultimately impressions from some greater reality here. Now, if you've seen our QuantSlob foundational series, this picture should look fairly familiar. A sample or data set is a realization from some population. This picture, however, as it stands, for our purposes, is incomplete. We need a third dimension to complete our triad. A mechanism, some process by which an impression has been manifest by reality. Now, the appeal of this broad relationship is that it is completely relatable. Even someone who has never seen a data set up close or someone without any understanding of stats can easily relate to this simply because everyone has impressions of the world around them. We are, all of us, host to personal impressions of countless themes. And as you can see, this is true even for Slobby, our favorite 3D emoticon here on QuantSlob. Okay, so question. Why is it that people may possess varied impressions of the same theme? So for example, consider the theme roller coaster. One person here may have gained the impression that roller coasters are fun and exhilarating, while yet another person may hold the impression that roller coasters are terrifying. For another example, consider chess boxing. Now, one person might say that chess boxing is an ingenious sport that tests combatants' intellectual and physical prowess, while another person may say, well, this is just the most ridiculous and baffling thing on the face of the earth. Okay, so you get the idea. Nothing earth-shattering here. Personal impressions vary. So how does this fit into our paradigm here? Well, I think in this context, it's quite clear that variability in personal impressions is owed, albeit in a potentially extremely complicated way, to what we're calling our mechanism here. Some mechanism or process that has somehow conveyed or coded snippets of reality into personal formative content. To really crystallize our thinking here, be reminded that there's a very familiar language or vocabulary around this. We speak commonly of externalities, things like fate, destiny, luck of the draw, and internalities as well, personal biases, inner self. Okay, so that's as far down this rabbit hole as we're going to go for this video, but we are right where we want to be. The mechanism, the third member of our triad, can be thought of here as a revelatory process by which reality manifests information. And if we are interested in how the impression of scientific information, like a data set, is differentiated from something like personal impressions, this is where we need to look. We're right where we need to be. So what is it that makes the mechanism that leaves the impression of scientific data different than that of personal impressions? Well, one thing I think that would come to mind for most people is simply measurement, or the science of metrology. A data set contains explicitly recorded attribute values, numbers, labels that are hopefully documented in a structured, consistent way and across well-defined units of observation. Another differentiator is that we or someone has attempted to take control and force reality to reveal itself or leave an impression in a particular way. And this, of course, as you could imagine, includes sampling methods like randomization. To repeat the point here, randomization or any other deliberate means of tapping reality is a property of the mechanism, which is why it is unadvisable to qualify an actual sample, an impression, as being random. Randomness is not a property of an impression or a data set. It is a property of the process that manifested it, the mechanism. In modern applied data science, data is what people work on all day. Sometimes parameter estimates and their standard errors are calculated, thereby tacitly suggesting some population. Sometimes the mechanism is explored, the means of sampling or measurement, but often only as a formality that has to be suffered through en route to the actual data set. And so in a data-driven world, we become, I think, too familiar with this hierarchy here. We mentioned in the Quantslov Foundational series that the population, here some subset of greater reality, is the cornerstone of stats. And this assertion is difficult to challenge, as much of the advancement of stats and probability over the last 2 centuries or so has focused on gaining understanding of our inferential population. And I certainly don't want to belittle anyone's data set, as some have resulted from years of labor, passion, and various forms of sometimes extravagant expense. But in truth, impressions come and go, data sets come and go. It is the mechanism, the process by which reality manifests information, that is the driving force, the building block of all knowledge. And this is true whether the knowledge be scientific in nature or personal or even anecdotal. The person you are today is a massive composite of impressions. But my question to you would be, how in the world did you get those impressions in the first place? It is the revelatory process here, what we have been calling simply our mechanism, that is the real superstar in all of this, center stage. And so I know what you're all of you are wondering. What does Slobby, our favorite 3D emoticon, think of all this? There you go. 2 thumbs up. That settles the matter. And that's it. That's going to do it this time around. Thank you very much for tuning in, and don't forget to stay tuned for more Quant Slob.